Hi everybody, this is Yousif Salih, chemistry teacher. Today, and as of today, we're going to have many lectures about chemistry, and we will start. Actually, I've forgotten to tell you that these lectures are provided by Ferxwaz website, and the admins will provide you more information, how to contact them or how to get benefit from these many lectures. So let's start. This is the very first lecture, mini lecture for grade 10, and we're going to study chemistry, section 1, chapter 1. First, let's understand what is chemistry. The term chemistry refers to what? We all know that we are surrounded by many materials, and including our bodies. So in order to understand what they are made up of, how do they behave, and the reasons after the change they undergo, chemistry provides us some clarifications about the composition made up of what. Of course, they are made up of what? Of atoms. Structure, how the atoms are connected to each other. Properties, when they undergo some change, how do they behave when they undergo some conditions, how do they behave. So chemistry is the study of composition, what the materials, what matter composed of, made up of, structure, how our atoms are bonded to each other. Of course, atoms get bonded to each other to form compounds, and our bodies and the materials around us, most of them are compounds, which means they are made up of more than one element that their atoms combine to each other, their atoms join to each other by what? By bonds. We will study this later, but today we will have a brief let's say brief definition for chemistry. So structure, properties, and processes that matter undergo. Processes that matter undergo. For example, if you burn a piece of wood, what would happen? What would product? What materials that change it into new materials? So these are the processes. This is an example about the processes that matter undergo. Okay. Later we have chemistry is the connection ring, or let's say instead of ring, we can say it's the connection ring, the connection link between it looks that doesn't work. Okay, this is the connection link between physics and biology. Why connection link between physics and biology? Because physics deals with non-living things. Yani matter, it means matter and energy. This is physics. Biology deals with living things, cells, organisms, and changes happen inside the organism's body. But chemistry deals with both of them. Chemistry deals with living and non-living things. So that's why chemistry is the connection link between physics and biology. Okay, now let's see branches of chemistry. Every science has classified into many branches. Why? In order to understand the fields that people work in. So because all science, physics, biology, chemistry, geology are wide, much wide. That's why there is a specification. There will be classification for the branches. So we have the main branches of chemistry are 6 branches. The first one is organic chemistry. What is organic chemistry? You see that organic, it was something, compounds, materials were someday a part of organisms' bodies. So the main element in organisms' bodies and later the material, the compounds that form from them, the main element is carbon. The main element in organic compounds is carbon. So organic chemistry is the branch of chemistry that deals with substances in which carbon is the main element. Carbon is the main element, such as what? We have, for example, alcohols, we have all types of sugar, we have proteins. These are all organic compounds. Of course, in addition to most of the fuel types, such as fossil fuel, gasoline of car, natural gas, and so on. So in all the examples we just mentioned, carbon is the main element. Carbon is the main element. But we have a question. Are all carbon compounds considered as organic? Are all compounds containing that contain carbon? Are all compounds of carbon considered as organic? So if carbon present, does it mean the compound is organic? Definitely no. The answer, definitely no. Why definitely no? Because in some compounds such as carbon monoxide, carbon dioxide, and carbonates such as CaCO3 that are present in the mountains rocks, these are not organic. Why? Because carbon here is not the main element. Carbon here is not the main element. Besides, they were not a part of organism's body someday. So that's why the answer for all or carbon compounds considered as organic compounds is definitely not, because we have carbon oxides, carbon monoxide, and carbon dioxide, and carbonate compounds such as calcium carbonate. These are not organic. These are not organics. Okay, let's move to next one. Okay, the next branch is inorganic compound. Inorganic compounds, it looks to be exactly opposite to organic. It looks to be exactly opposite to organic. Inorganic, the branch of chemistry that deals with substances in which carbon is not the main element. Carbon is not the main element. Such as what? We have acids, inorganic acids, of course, because we have some acids are organic, and we have what? This is acid and this is acid. Also, you have salts, acids and salts. These are all inorganic. These are all inorganic because carbon in them is not the main compound. It's not the main. Sorry, this is not the main element. It's not the main element. So far, we have two branches of chemistry. Organic chemistry, carbon is the main element. Inorganic, in which carbon is not the main element. Carbon is not the main element. Okay, let's move to the third one. The third one is physical chemistry. Wherever you hear the term physics, physical, it flows into your mind, change of energy, energy transferred, energy lost, energy gained, energy converted from a form to another form. So here physical chemistry deals with the properties and change of matter and their relationship to energy. So wherever we related the change of matter into energy, so we have the change and their relationship with what? With energy. Whenever we see an issue, in a problem, in a topic that chemical change related to amount of energy as heat, for example, or even as electric energy transferred or gained or lost. In this case, we're dealing with what? With physical chemistry. We have an example here. Calculating amount of heat energy released when burning 100 grams of car fuel, gasoline. Car fuel, of course, car fuel is C8H18. This is the main compound in car fuel, and this is called isooctane. This is called isooctane. Okay. So when you burn 100 grams of isooctane and you do some calculations to calculate to find the amount of heat released, the amount of heat earned when you burn this 100 gram of isooctane, in this case you're working in a field of physical chemistry. Okay, now let's move forward. The fourth one is analytical chemistry. Analytical, which means analysis. You analyze something. You analyze something, you want to its composition, you want to know its composition, made up of what. And also, you need to know the percentage of the material, the substances that form this sample. So for example, if you have a sample of rock and you make some processes in order to determine the composition and percentage composition. What is the composition of carbon? What is the composition of sodium? What is the composition the composition percentage here. In this case, you're dealing with analytical chemistry. But in our daily life, a patient visits his doctor, and his doctor refers him to the laboratory. And he goes to the lab, and the lab man makes some tests for him in order to determine the blood sugar in his blood. Blood sugar. So for example, he will tell him, okay, your blood sugar is 90 milligram per deciliter. 90 milligram per deciliter. So he made what? He made analytical chemistry. He analyzed the patient's blood, and he told him that his sugar percentage or his sugar composition in his blood is 90 milligram per what? Per 1 deciliter. Also, we have many of them. So for example, determining the urea in a patient's blood. This is also another application of analytical chemistry. Okay, now let's move forward. We have biochemistry. Biochemistry, okay. Biochemistry, it's the branch of chemistry that studies substances and changes occur in living things. We have here especially inside, we will say here, especially inside what? Inside the cells. Inside the cells. We know that many chemical change happens inside the cells. So for example, cellular respiration. And we have in plants, there's photosynthesis. We all know what is photosynthesis. Photosynthesis is when the plant absorbs here, when the plant absorbs CO2 from air and water from roots to produce sugar and what? And oxygen. So for example, a glucose sugar, C6H12O6 plus O2 plus oxygen, O2 of course. This is not balanced equation because we have 6 carbon atoms here. We have only 1, so we're going to add coefficient of 6 here. Now we have 12 hydrogen and we have only 2, so we're going to add also 6 here. And we have oxygens here. Of course, in the next grade, we will study balancing. Anyhow, we will need also a coefficient of 6 here. This process occurs in living thing. Which living thing? It's plants, in the cells of plants, and especially in leaves of plants. So the one that we just mentioned is what is an example about what? An example about biochemistry. And finally, we have theoretical chemistry. Theoretical chemistry. What is theoretical chemistry? When you hear something called theory, theory means something related to mathematics, computer, which means not application, not applicable, and let's say no materials used. The only things that we use in theoretical chemistry is the computer, okay? Computer programs. We use computer programs. And beside, we need mathematical principles. Why do we use those two tools, computer programs and what? And mathematical principles, in order to understand and predict behavior of new compounds. So we have a new compound that's prepared, and we need to understand its behavior and its properties and predict how would they behave if undergo some circumstances, some conditions. So we use computer programs and mathematical principles in order to predict their behavior. This is the last branch of chemistry, which is theoretical chemistry. Let's move to another topic. The next topic, okay, we have here some samples of matter can be called chemical. So for example, drugs, the medicines that we buy from pharmacy, we call them what? We call them chemicals. Other samples cannot. So for example, a piece of clay, you cannot say it's a chemical, okay? A piece of wood, you cannot say it's a chemical. So what the term chemical means, it's a sample of matter that has a definite noun composition, So here, the condition to call something chemical, it must have definite noun composition. So for example, when we say we have water has definite noun composition. So water is a chemical, okay? Carbon dioxide, CO2. Each molecule of carbon made up of 1 atom of carbon and 2 atoms of oxygen. Also sucrose. Sucrose is a bisaccharide. Each molecule of sugar, sucrose, composed of 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. So can we call sucrose a chemical? Yes, we can. Why? Because it has a definite composition, and its composition is noun. Let's move forward. We have also types, sorry. Okay, we have types of scientific research. Types of scientific research. There are many types of scientific research, but actually they can be classified into 3 main types. According to what? Basing to what? Depending on what? Depending on the target, the aim, the goal, why it is being done. Why should we do this research? So the first type of research is basic research. Basic research is a research that carries out for increasing knowledge, which means you only collect what? You only collect information about a new substance, about a new phenomenon, about a problem, about a new disease. So basic research is a research that carries out for increasing what? Increasing knowledge. We have many examples, of course, but let's keep in mind, basic research does not suggest any solution for problems, does not suggest solutions. It's only collects information. It only increases our knowledge about a new material or about a problem or about a new phenomenon. So let's see the examples. We have first one, collecting information about a new generation of coronavirus. It is only collecting information, collecting data. About what? A new coronavirus. So let's say it is COVID-19. Let's say COVID-19. In this research, the researcher did not suggest a treatment for this virus, did not suggest a vaccine. He only collected what? Information. So he's in the beginning. So the basic research usually is the beginning of the solution. It's only collecting what? It's only collecting information. So this is the first one. Second, detecting the reason. Find the reason why of ozone layer damage. We know that in the beginning of 80s of last century, there was a serious problem in ozone layer. The problem was there is a gap happened in, let's say, a pinch. Happened in what? In ozone layer close to North Pole. So the first thing scientists did is to know why this happens. Why ozone layer getting damaged? Why this hole happens? So it was only to decide the reason, the cause. Only. So this type of research did not suggest a solution for repairing ozone layer. No. It only decided the reason of ozone layer damage. So this is the first type of research that aims, that carrying out, being done only for increasing what? Increasing knowledge. And no solutions suggested. Okay, the second type of research is applied research. Applied research, application, doing something. So any research that suggests what? Solutions for existing problems, which means you have a problem, such as the problem here of COVID-19 or even ozone problem, and applied research doesn't collect information. It suggests what? Solution. It suggests a solution. So for example, we have here in the first example, suggesting HFC gases, hydrofluorocarbon gases, as a replacement of chlorofluorocarbon gases in cooling and freezing systems, because hydrofluorocarbon gases are safe and do not harm ozone layer. So here is what? Here is the solution. In basic research, just they made determination about what? About the reason. Detecting the reason. But in applied research, the researchers suggested hydrofluorocarbon gases to be used in a fridge, to be used in systems of cooling instead of CFC gases. CFC gases were used. So here we have Ferrion 11 and Ferrion 12. Ferrion 11 and Ferrion 12 were used until the end of 80s in cooling systems and fridges. But a decision made in United Nations that banned use of CFC gases, blocked use of CFC gases, and they forced the companies to use hydrofluorocarbon gases instead of what? Chlorofluorocarbon. Why? Because hydrofluorochloro gases are what? Are safe. They don't harm what? They don't harm ozone layer. Okay, we can see this is an example. Another example is suggesting solutions for global warming. What is a global warming? Let's have a clarification for global warming. Global warming is what? Is gradual increase in atmosphere's temperature. يعني it gets hotter. It gets hotter. This is the problem. So here suggesting what? Suggesting the solution. The solution here is what? Is using clean energy sources instead of fossil fuel. Fossil fuel is gasoline, gas oil, natural gas, and these all cause global warming. But when we use clean energy sources, such as what? Wind energy, such as water energy, waterfalls energy, such as solar energy, of course, well, this would be supportive for environment, because this reduces the amount of carbon dioxide released to atmosphere, and carbon dioxide that released to atmosphere cause block of heat from escaping outside the atmosphere. So here the solution is suggested to use clean. The solution is using what? Using clean energy. This is the solution. So the research that made in order to solve the global warming is using clean energy, using clean energy sources. What are clean energy sources? Solar energy, wind energy, and waterfalls energy. Okay, this is the second type of research. The third type of research is technological development. You see, it's development, which means there is no problem. There is development, there is enhancing, making things better. In technological development, we don't have a problem to solve. No, we have products and we suffer with it, but we want to improve our life. We want to improve, to make our life healthier, safer, more joyful, happier life. So here, the research that aims, which means done for, to improve quality and use of existing products, which means the products present already. The products present already, but what we do here is to improve them, to enhance them, to make them better. In order what? To earn healthier, easier, and happier life. So for example, you have your own computer. You have your own computer, like the computer here. Like this computer here. It feels a little bit heavy. Besides, it's not as fast as required. So the researchers in this field will design a new model of computer. That computer can be lighter in weight and faster and maybe wider in storage. So in this case, we had a computer and we got settled with it and it was okay. But we want to improve in order to have what? To have life better. That's why they designed a new computer. This new computer is lighter. You can carry it easier and transfer it into your school, into your company. Besides, it is faster. It makes work done sooner. As well as the storage. The storage is better, which means wider unit of storage. So this is one example about what? About technological development. The second, designing a new car exhaust catalyst. The car exhaust unit most in the back of the car and releases the gas. Most of the gas here is carbon dioxide, carbon monoxide. And when using bad fuel, maybe ions of lead that are carcinogen, which means they cause cancer. So designing a new catalyst or new exhaust for a car that reduces pollution. Of course, this would be technological development because we already have cars, but we want to improve our cars in order to have cars that are not harmful to environment, not pollution. And we might, of course, there's a designing of new cars, electric cars, better than existing cars, despite they are expensive, but they don't cause any pollution. They don't cause any pollution. Besides, some many new features are added to cars to get them more comfortable. Okay, this is also an example about what? About technological development. Let's move to the third one. The third example about technological development. We all use toothpaste in order to brush our teeth daily, maybe twice a day. So the designing of new toothpaste, we had toothpaste, of course, and we settle with it. It's okay. But if there is a new toothpaste that odors, smells better, and protects our teeth enamel, of course, protect our teeth enamel from corrosion, this would be better. So a person that makes technological development in this field, and field of toothpaste, makes mouth smell better after using the new toothpaste, and provides more support to what? To teeth enamel. And this makes life, of course, healthier, safer, and let's say more joyful, happier. Now, this is all about section 1. It's actually a short section. So we can move now into the section review. In section review, we have only 3 questions, and they are also short. Most of them, we talked about them earlier in the beginning. So the first question is define chemistry. Define chemistry, we said before, chemistry is study of composition, structure, properties, and change that matter undergo. Composition, structure, properties, and processes or change that matter undergo. This is the first question. The second question, name 6 branches of chemistry. Of course, when repeat them many times and write them, you will not forget them. You will not forget them. That's why it's recommended to you when you study, first study, especially when the topic is clarification. The first thing is to read with high voice. Second thing, try as possible, try to write the things that you want to memorize. So if you write the branch of chemistry many times, so you will not forget them. You will not forget them. So let's say them together. We have the first one is organic chemistry. The second one is inorganic chemistry. We had physical chemistry. We had analytical chemistry. We had biochemistry. And finally, we had theoretical chemistry. When you repeat them many times and write them, we will not forget them. The third question in section review is compare and contrast types of scientific research. We just talked about them. Basic research and applied research and technological development. Of course, here the definition itself can be contrast. We can distinguish with them from the definition. So, for example, for which reason the basic research is done? It's only for increasing what? Increasing knowledge, increasing information, collecting information about a new substance, a new matter, or a new problem or phenomenon. But it doesn't suggest any solutions. This is applied research. This is the basic research. Applied research is a research that suggests solutions for existing problems. There is a problem and you want to solve it. There's a problem and you want to solve it, such as the examples we just said about the ozone layer and how suggesting hydrofluorocarbon gases, HFC gases, as a replacement to CFC gases that were used in 80s of last century. And it was actually fair results. The ozone layer gets healed, gets recovered after using HFC gases. The third, technological development. Technological development doesn't solve problems because already no problem. But it improves and enhances the products in order to have better quality of life. Better quality of life to make life safe, more safer, and to make it healthier, to make it easier. If you add to this question some examples, if you get it in the exam, it's better. Of course, the examples that we just said can work. So here we said many examples. So for example, here the basic research, collecting information about what? About a new generation of coronavirus. Okay, it's a good example for what? For basic research. For applied research, using what? Using or designing a vaccine for a fatal virus. You see here we have the problem. We have the problem here. It's only collecting information basic, but here it's designing a vaccine for a fatal virus, such as HIV virus or coronavirus or any other virus. About the technological developments, also you can use any example of these or any other examples. For example, designing a new car exhaust or catalyst that reduces pollution, and so. This section actually is a short section. and it's only introduction to chemistry. Next section we will hopefully we will have let's say talk about the smaller or microparticles of matter, such as atoms and molecules, and how the atoms how are bonded to make molecules, big molecules, or small molecules, I mean simple molecules. So until we meet again, take care, and if you have any clarification, you can contact the admins of the website, Ferxwaz website, and I'll be very, very happy to respond to you as soon as possible. Have a nice day.